Hello, algebra students. Mr. Lawrence here, and we're going to do something new today. We're going to review the solving inequalities. That's why it's called Solving Inequalities Day 2. But we're going to have a little quiz at the end. There's going to be a quiz problem. You can see at the bottom of the screen it says quiz problem. You are responsible for doing this problem and bringing it in to me tomorrow, and it is going to count as a quiz question, okay? This is an attempt to hold some of you more accountable. Some of you kind of blowing off the videos. That's not acceptable. You got to do your best. Why? Because you deserve to do your best. So make sure that you are doing what you need to do. All right, first off, let's talk about problem number 1 here. Now, I'm going to solve this inequality, which is going to be very much like solving an equation. It's going to be very much the same. And you can see I have a 3x minus 5. It's less than 10. I know my first step is to add 5 to each side. Hold on a second. There we go, add 5. And you might be wondering what I'm doing. Well, I've forgotten my airliner at school, and so therefore I have to show my work this way, but it will be the same thing. And so I draw my line, and that will leave me with the new equation, or inequality, 3x, and that will be less than 15. Okay, notice how I try to have everything pretty much lined up. It's a little bit off because my typing's off, but I'm still lining everything up. All right, my next step will be to divide by 3 because there's a 3 attached to the x. So I'm going to divide by 3. I'm going to divide by 3 on both sides. So let me get a couple of 3's out here and another 3. All right, and when I do that, my new equation becomes x, and it becomes less than 5. All right, now that is my solution. That's my mathematical sentence. Now a solution set, like somebody asked about in an email, a solution set is where you tell me all of the numbers that can be a member of 5. That can be a value for x and make this inequality true. So remember last week we talked about the number line and how there are just way more numbers on a number line than you ever thought possible, right? And we call those the real numbers. There are more real numbers on a number line than there are stars in the entire universe, okay? If you could find 2 universes, which, it wouldn't make any sense, but let's pretend you could, there'd still be more numbers on a number line. So here's how we present the solution set. We start with one of these guys, and then we use our variable, and we say x. We say x is any real number. Okay, usually that r has an extra bar, but I don't have the right font on here. X is any real number, that's how you read it. Okay, so in other words, x is any number on the number line, and then you put this little line in here, this vertical line, such that, that little line is read as such that, and then you repeat that x is less than 5. Okay, that is the solution set. That's how we say it in mathematics. Okay, and some of you go, well, why do I need to say it that way? Because you need to understand that we're dealing with a set of numbers called the real numbers. Why are they called the real numbers? Well, there is a set of numbers called the imaginary numbers. Now, we won't use the imaginary numbers in here, but you'll hear me mention them from time to time. Okay, so this right here, let me highlight it if I can. Get my highlighter out here. Okay, so this is read as x is any real number such that x is less than 5. Now, if I made a number line, this would be my graph. That's the third way to present my answer. Okay, I'm going to make a number line, and I need to put an endpoint, an arrow point on the other end. Sorry about that. Just take me a minute here. Okay, now I have to show a couple of numbers on my number line. I don't have to show a whole lot. I'm going to show 3. Okay, now it doesn't matter what 3 I show as long as one of them is 5. Why 5? Because it was directly involved in my solution. X is less than 5. So I'm going to show a 5 on here. Where'd you go, 5? And I like to put the number that shows up in the solution in the middle. Okay, so maybe I'll choose 4 for the other point, and I'll show 6. All right, so is Are there only 3 numbers on this number line? No. There are an infinite amount of numbers on this number line. I'm only showing 3. Now, to show this properly, I need to indicate the point where everything is happening, and that would be at 5, right? Okay, and so I have this open point here. Why is it open? Because it's not equal to. And then I need to test. I need a number that is less than 5. Okay, let me put it up here. And I'm going to fill in this blank. Blank is less than 5. Well, let me think of a number. I know 0 is less than 5. So I'm going to put that on the blank. I've got a true statement. And since 0 is less than 5, that makes it true. I'm going to shade toward 0 from the open point at 5. Okay, I apologize for this not looking better. But I'm not using the airliner. I'm using the mouse pad. So there's your number line. Okay, so I presented my answer in 3 different ways. The first way was this, the solution, the mathematical sentence, the inequality. Then the solution set, this one highlighted in yellow, and then the number line is my third way. Okay, let me get rid of some of this stuff here, get it out of my way. And I'm going to come over and solve this next equation. Now, very much like what we were doing in class the past few days, I'm going to get rid of this 8 first, so I'm going to have to subtract 8 from both sides of the equation. All right, so I'm subtracting 8, and then I draw my line, and that will leave me with, and this is a pain, but that's okay. I'll do this. All right, and bring my 2 down. Fractions are a pain without the, and then that's going to be less than 12, I believe, less than or equal to, something like that, right? Okay, now, to get rid of this fraction, I'm going to multiply both sides by 2, because 2 is in my denominator. But I'm actually going to multiply by -2 on both sides. In fact, on the left-hand side, I'm going to do it as a fraction, -2 over 1. Where's that 1 at? Okay. And so that's going to be multiplying. And I really should put parentheses around that because it doesn't look like a multiplication problem. And so let me put that there. Right? Okay. And then, of course, on the other side, I need to multiply by a -2. Oh, that worked out real nice. And close my parenthesis. That's not a parenthesis. There we go. That looks more like a parenthesis. Okay. Let me redo that because that looks pretty screwy. Okay. About like that. That's a little bit better. All right. Now, Wonder Woman's going to show up, and she is going to cancel out these 2's. And, of course, the 2 negatives will also cancel because a negative times a negative is a positive, leaving me with an x. Now, on the right-hand side, I'm going to get a -24. But I multiplied by a negative on both sides of the inequality. When I do that, the inequality, the symbol has to change directions. Okay, and I showed that in the one video. So now, this is one solution right here. There are not one solution. This is one way to present the solution. And this is the mathematical sentence, right? And let me move that over here. Seems my x doesn't want to move. That's okay. I'll get a new one right there. So x is greater than 24. Now to show the solution set, I'm going to start that little thing like that, that little brace there. Okay, my variable is x, and x can be any real number such that, and then x is greater than or equal to -24, and I close that brace, and I guess I should kind of do that, give it some more room. There we go. All right, so there's the solution set. So I did the mathematical sentence, I did the solution set, and now I'm ready to do my number line graph. Now I'm not going to show 4, 5, and 6 on here because I'm dealing with a negative 24. Maybe I'll space these lines out a little bit more, and I'm going to get negative 24, and I'll put that right in the middle. And I'll also need a negative 23, which is greater than negative 24, right? And then a negative 25, and that will be there. Okay, so let's see, I've got a point at negative 24, although this time the point should be filled in. It should be a closed point. Why, you say? Because it's equal to. It says greater than or equal to. Fill effect, solid fill. There we go. I like that. And then I'm going to test it. Always, always test it. Don't just go, oh, it shades this way. I think it shades that way. No, always test it. It's too easy to test. Put a blank. We've got a greater than or equal to negative 24. And I'm going to fill in that blank. So give me a number that makes that true. Well, let's pick a positive number, like say 5. Okay. Well, where is 5 on this number line? It's going to be to the right of negative 24, won't it? So I'm going to shade towards 5. Okay, there you go. All right, so here's the new portion. Here's what's going to happen. Here's your quiz problem. It is only this problem right here. Okay, you need to write that down. You need to do your best to solve it. You're going to present it 3 ways. You're going to give me the solution, x is greater than 5 or x is less than negative 2. You're going to give me the solution set, where you use this guy. Oops, let me move him down. We use this guy and state that x is any real number such that, and then you tell me, like x is greater than 5. Of course, this is not the solution. I am just giving an example. So this is the second way you need to do it. And the third way you'll need to do it is on a number line. Now, I'm going to collect this from you tomorrow, and it is going to count as a quiz. Okay? So make sure you do your best on it. Make sure you give a full effort. If you don't have it tomorrow, you'll have to hand a note in that I did not watch the video and I'm taking 0 on the quiz. All right, that's it for today. Mr. Lawrence signing off. Have a good night, everybody.